Here we're given the tan ratio of negative 1.4. So tan really should be related to slope. So basically we have a line of slope negative 1.4. So if I were to draw this in, that's what it looks like. And there's basically two spots on the circle that we can intersect. Okay, so there's going to be two spots here and here if we have a negative slope of negative 1.4. So I'm just going to draw my rise and run. So that's going to be negative 1.4, negative 1.4, and then that's going to be positive 1.4. That position is positive, and this x position then ends up being negative, and that gives me my slope of negative 1.4. If I draw my triangle over here, my position is negative 1.4 for the y, and positive 1 for the x, which also gives me a slope of negative 1.4. So those are my two spots that I'm using for my to show this tan ratio or slope of negative 1.4. So I want to find out the length of that hypotenuse. Okay, so I'm going to use the decimal value here of 1.72 about. Okay, so that's the length of my hypotenuse. So if I want to find the sine and cos ratios, okay, so sine ratio goes with the y coordinate. So it's going to be, well, there's two of them, and I'm going to call one theta 1. Okay, and maybe I'll color code these a little bit. Let's do this one in, I'll do this one in blue. So I'll call this one sine theta 1. And theta 1 is going to be this angle down in quadrant 4. Okay, so sine of theta 1 is going to be negative 1.4 over 1.72. Okay, so that's going to be about 0.81. I'm going to round that to 0.814. Okay, so there's my sine ratio for theta 1. But there's also a sine ratio that relates to some other position over here. Okay, that one I'm going to call theta 2. So the sine ratio for theta 2, okay, is the same proportion, so it's going to be 1.4, and the hypotenuse or the radius is 1.72. So it's just the same, and I forgot the negative on the other one, so this is just going to be 0.814, and the one in quadrant 4 is negative 0.814. Okay, and then for the tan ratio, for the cosine ratio, we have to do the same thing. I have a cosine of one position, which is theta 1, and that's going to be 1 over 1.72. Okay, so 1 divided by 1.72 is about 0.581. So 0.581. Okay, and then we have the same thing happening for theta 2. So cosine of theta 2 now is in quadrant 2, and the cosine values are negative in that quadrant. So I end up with negative 0.581. Okay, so then finding the angle in standard precision, I have to find both angles. So I'm just going to do the inverse tan of 1.4, negative 1.4. And I'm getting an angle, so I'm going to call this angle theta 2 and theta 1. So the angle that I'm getting from my calculator is negative 54.46 degrees. Okay, and we have to figure out the other angle here in quadrant 2. Now, that other angle in quadrant 2 is exactly 180 degrees, or on the opposite side of the circle. So I'm just going to add 180 degrees to get that position, and that position is at 125.53 degrees. Okay, so those two positions are two different positions, but they give me the same triangles. But again, because there's two different positions, I need two different angles, And the sines and coses are different for both of those angles.